Hello everyone. So in this particular video, we will discuss about performing linear convolution of two sequences. Okay, on this particular platform. So what's the catch, by the way? Linear convolution of two sequences. Well, uh, there are two things basically. First thing is we want to understand how the algorithm works. Second thing is we want to learn MATLAB too. So uh, actually linear convolution is very simple. Let me just show you demo here. Suppose I want to convolve what these numbers are. Suppose I want to convolve 1 2 3 4 with 1 2 1 2. What I have to give is I have to simply go to MATLAB and type conv, and then I just need to give this two variables. Either you assign them certain variable names or you just give them in bracket. Okay, wait, see here I'm doing this using a comma separator. So there I got the answer: 1 4 8 14 15 10 8. Okay. So linear convolution is real simple. So but there are two things, as I keep telling. Let us learn MATLAB also. Let us try to understand looping. Let us see how to go about a program, apply your own logic and all those things. That's why I thought let us do this particular function, linear convolution, do the program without using the ready-made function conv. And there is one more catch. This particular function, it does not ask us what is the starting point of the first sequence or the second sequence. It simply takes in numbers, gives us the values. We don't know where would this start from. If at all I plot it, it will start from 1, whereas in our notebooks and textbooks usually starts from 0, right? So yeah, all those things. That's why it makes sense that we write our own program. Now that we know the answer, and in case in exams, if at all you get into trouble, use simple co in your function and defend your answer. That should be fine. But let us see the proper way of doing this. Okay, so yeah, here it is. So what's the catch, by the way? So here is a program where we will write it without using the conv function. Okay, without the conv function. Okay, so what do I do? So I will read out the two inputs. Okay, so I want my program to be interactive. Okay, I want my program to be interactive. Every time I want to be able to change my inputs, interactive. That's why you can see here the both the sequence. I'm asking the person who is running the program. I'll let him enter the values. So two things I'm asking the sequences, and also I'm asking the starting point of the each of the sequences, because my sequences never necessarily start from 0. They can start from -1, they can start from +2, and so on. That is why name the variables x1 and x2 are my two sequences. Okay, x1 and x2 are my two sequences. Now do not get confused with x and h. Okay, here I'm using x1 and x2. Okay, as the naming. Okay, so sp1 is the starting point of first sequence, sp2 is the starting point of the second sequence. Okay, so what's the deal with the starting point of the answer? I know one thing, that if the starting two things, okay, if the length of the first sequence is 4 and length of the second sequence is 4, my answer is going to be length of the first sequence plus length of the second sequence minus 1. This is going to be the length of my answer. Let me end it with a semicolon here. Okay, so that is why what I'm doing is when I want to plot, I want to have my x-axis correctly. That is why I'm keeping track of all these things. Okay, so what did I do? I read out the first sequence, I read out the starting point of the first sequence, then the second sequence, starting point of the second sequence, then say here I'm using the function length. Okay, now this is going to return me the length of the first sequence, because it's one dimensional thing. It's going to return me whatever length, 4 6 7, whatever, and then length of the second sequence. The length of my answer is going to be the length of the first sequence plus length of the second sequence minus 1. Now since I am doing this particular thing instead of using the ready function, what I want to do is, whenever there is this formula, right? What is the formula? Y of n equal to x of k h of n minus k with the summation. Okay, in our case this is x1, and this will be my x2, right? This is our typical looping. Then the summation means, so this is the accumulation part. Okay, so whenever I do this, when the length of first sequence and second sequence is there, the scenario is going to be something like this. Okay, Suppose I have my 1 2 3 4 and 1 2 1 2 as my two sequences. You have done this in your notebook also. So what do I do? First I take my 1 2 1 2, the second sequence. First I multiply, what is it? X of k multiplied by h of n minus k. That means my second sequence, you can see here 1 2 1 2 is kept on shifting. Okay, my second sequence I keep on shifting. Then I multiply with the first sequence, individual element of the first sequence. Then I add the individual outputs. Okay, so once again, should I repeat how does it work? So what do I do is, wait again, let me just, okay, now this is fine. So x of k, you can see this is x of k, first coefficient, k equal to 1, k equal to 2, k equal to 3, k equal to 4. X of k, h of n minus k. This is the entire sequence, h of n minus k. First with the n minus k, shift equal to 0, k equal to 0, k equal to 1, shift by 1, k equal to shift by 2, k equal to 3, shift by 3. Now MATLAB gets really irritated when you have only 4 elements and then you go on trying to find the fifth element as part of the formula, because the summation k tends from minus infinity to infinity. Take all the values where there is non-zero. That's what MATLAB says. But then you do not have the values there. MATLAB expects of, and you get errors, right? Missing values. That's why what we are doing is we are not taking chances. We are stuffing in these zeros here. You can see we are stuffing in this zeros. Okay, let us do a trick here. So if the length of the first sequence is 4, length of the second sequence is also 4, then we know that the anticipated length of my answer is how much? Around 7, right? That is the anticipated length of my answer. Length of the first sequence plus length of the second sequence minus 1. So let us append how many zeros? Sufficient number of zeros. So what I have done is, other than my 1 to 1 to, I added 1 2 3 4 number of additional zeros. I think 3 number of zeros would have done. Okay, 3 number of zeros would do. You can see, yes, okay, 3 number of zeros should be sufficient, so that as and when I go on here and multiplying and adding, I want to be all the values to be declared. Otherwise what's going to happen, unless you declare, the values are not going to be there. Some junk values will be taken up. Okay, we got this particular thing. So what I need to take the first sequence, the individual elements of first sequence as one of the multiplicants. Then the second sequence I have to take, I should keep on shifting it. Then third thing I have to do, or I should do it initially, is append the sufficient number of zeros. And what I'm going to do is, I'm simply appending the sufficient number of zeros once. Then I keep on rotating this thing only. You can see this is once. I'm going to shift this. Now I'm going to use the command circular shift. When I use the command circular shift, you can see one moves here, two moves here, one moves here, right? All the values are moved to the right side, and you can see this 0, which was here, this has moved in this particular corner, so that I need not append zeros on either sides, from the right also and from the left also. Okay, so that's why I will use the command circular shift. Okay, so here is the program, as you can see. Wait a second. So now I have told you. So what I will do is, for both the sequences, for first sequence also, I will append sufficient number of zeros. How many zeros? If at all, length of the first sequence is 5, length of second sequence is 3. My expected answer is 5 plus 3 minus 1. So first element 5 should be appended with 2 zeros. Second element 3 shall be appended with around 5 zeros, is it? Yeah, 4 zeros. Okay, that's how it is going to be roughly. Less number of zeros are going to create an issue. More number of zeros is fine. Okay, so I think I have 1 0 extra here. Okay, so you can see initially. Okay, so I will run this program. We will run this program, so have a better feel of it. So that's what L1 plus L2, and this is what I told. What is my intention? Why I'm appending zeros? Okay. Now what I'm going to do is, you have been doing this, right, in your notebooks also. First you do this particular multiplication, you write it at once. Then you do the second multiplication, add the result with the first one. Then you do this third multiplication, add the result with the previous. Then you do the fourth multiplication and add the result with all previous. So you go on accumulating, right? So that's why what I'll do is, so let me take an anticipated answer y, as let me simply initiate it as 0. So length of the first sequence is 4, second sequence is 4. I'm anticipating a length of 7. So I've simply initialized a sequence of 7 zeros here. Okay. Then what I will do is I will go on accumulating my answer there. Okay. Then the second thing what I'm doing is I will take a variable a, okay, which is equal to a to L1, the first sequence. I will take the variables of the first sequence as a multiplicand, right? X1 of k, x2 of n minus k. So I will take this x1 of k, the first term, and instead of k, I have used an a. So I will go to x of first element, second element, third element, and fourth element. So from 1 to length of the first sequence, okay. Then I will multiply it with the second sequence, element by element. So this is, I am taking, this is a single element from x1, and this is the entire array x2. Okay, so dot multiply or a simple multiply, it will work anyway. So once I get this particular multiplication, then what I will do is I will take this y, which is currently zeros. Then I will add it with this particular temporary result, whatever you have, temporary result, okay, that particular temporary result. And then why I have used the command circular shift, let us see here. Okay, first when I will take x1 of k and x1 of k and complete sequence x2, right? I will multiply it. First, when I multiply the first sequence, when I do it for the first time, I do not want any shift. But when I do it during the second instant, whatever the term, this entire thing is multiplied, I just want it to be shifted by 1 unit, then I want it to be shifted by 2 unit, then I want it to be shifted by 3 unit. Okay, after the multiplication, fine, after the multiplication, okay, the whole shift is done. That is why here I can say I did not multiply it with 4, or I should say this will result in what, 0 0 0 4 8 4 8 0. That's what I mean. Okay, so as you can see here, first I multiply the individual sequence x2 with the individual elements of x1. Then afterwards, while accumulating, I shift them. Then I accumulate x1 of k, x2 of n minus k. I shift the individual results, then I accumulate, shift and accumulate. So yeah, that's how the looping works. And finally, coming to the plot part, you can see if at all my answer, suppose my starting point of the first sequence is -2, starting point of the second sequence is 0, my answer should start from -2 and till where it should go, so the length of the sequence is going to be 7, right? So -2, -1, 0, 1, 2, 3, 4. That means from your starting point, if your starting point is -2, it should go till, from where, start from -2 and go till -2 plus 7 minus 1. Okay, till there it has to go. So that is how I will declare my x-axis, the time. Okay, and I will display the answer using stem. Okay, n comma y, which is my result. Now let us run this program as a whole. Let me run this particular program as a whole. So here, let us simultaneously have a look at the workspace. So first, whenever I do this clear all, you can see workspace gets clear. Okay, no nonsense here. Okay, now let me just execute this first 4 lines. Okay, so the first line here, yeah, enter the first sequence. So what is it? 1 2 3 4. That's my first sequence. Then starting point of the first sequence. Okay, so here the starting point of the first sequence, as I told you, what shall we take? My starting point of the first sequence, I should take say -2. That's what I've been telling, right? Okay, then x2, uh, second sequence x2, 1 2 1 2. That's my second sequence. Then starting point of the second sequence there. So -1, let me have it as -1. Okay. Now observe the workspace carefully. X1 is of length 1 2 3 4. This is 1 2 1 2. Both are 1 cross 4. Now we'll read the length of the first sequence. Length of the first sequence, you can see I'm using the command L1. It is returning me a 4. Length of the second sequence also, this is also returning me a 4. Now you can see the total length of the expected anticipated length of the result. Okay, that is returning me a 7. Then what I will do, now see x1 here. X1 for the timing is a 1 cross 4. Now what I will do is I am going to append x1 with additional zeros. That means if at all my length of the sequence is, wait, let me run this particular thing. Okay, now you can see here my x1 has gone from 1 cross 4 to 1 cross 7 because my answer is anticipated answer is of length 7. And whenever I do on this shift thing and multiplying, right, that time I do not want any missing values, right, when MATLAB tries to loop. So you can see first value, 4 values, 3 zeros have been appended here in this particular thing. You can see similarly we do it for the second sequence also. You can see now when I execute this, my x2 size is also going to change. So both of them are of same size, and y is my initial answer. You can see y is my initial answer 0 0. As and when you go through the loop, as and when you go through the, my answer builds up. So let me run this particular thing. Let me end this thing with a semicolon. I do not want any intermediate answers to pop up, or should we say it? No, you can remove. So the curious programmer, what it does is it removes semicolons and keeps on checking individual values. You can see now my y, my final answer has accumulated here, but it's not done. This particular y here does not give me any information from where does my answer actually start from. So for that, what I will do is I will use I will define the starting point of the answer as starting point of the first sequence plus starting point of the second sequence. So it is -3, and then now I declare a time axis, right, the x-axis. Okay, so it should start from, let me type here, okay, okay, see, -3, -2, -1, 0, 1, 2, 3. So that sequence length is totally 7. Display the convolution result. I will display the thing on the screen, and you can see the convolution result is, and here we have the graph. Yeah, that's the graph. So that was the simple experiment on linear convolution. We made it complicated by not using the ready function, but at least there can be innumerous ways of doing the convolution. You can have your own way, and in the end it should work, and it should work for different types of sequences. Okay, it should work for sequences of different lengths. Okay, so you can also try an efficient program if it can be better. Okay, always, you're always welcome. Okay, so that's that. Let me stop here.